Here we have a logarithmic equation and we have to solve for x. Okay, when I look at the logarithmic equation, on the left side, we have addition of two logarithms with the same base. Whenever two or more logarithms are in addition with the same base, what we need to do is we have to take logarithm once with the base, what we have for the logarithms, and we have to multiply the arguments. That is x times x negative 2. Actually, this is a product rule of logarithms. Okay, so on the right side, I'm taking the stuff that is log x positive 10 to the base 3 as it is. Here, two logarithms are equal with the same base. Whenever two logarithms are equal to the same base, we can equate the x arguments. So then I'll be getting x times x negative 2 equals to x positive 10. So x times x is x square and x times negative 2 is negative 2x equals to x positive 10. Okay, here I got a quadratic equation, but it's not in standard form. Standard form means we must have 0 on the right side. So for that, I have to get rid of this x and positive 10. For that, I subtract x from both sides, and also I subtract 10 from both sides. Then x, negative x cancel, positive 10, negative will cancel out, x square. When I combine these two, I'll be getting negative 3x, and at last we have negative 10 equals to 0. Okay, now we have a quadratic equation standard form. Okay, now let's try to solve this quadratic equation by factoring. So here the coefficient of x square is, actually there is no number in front of x square. So I have to assume there is a coefficient 1 for x square. So in that case, I have to take the constant term over here. And now I have to get two factors for this constant term negative 10. So that the product is equal to negative 10. And the sum is equal to the middle term or the coefficient of x, which is negative 3 in this case. I think negative 5 and positive 2 will work. Because when I multiply them, I'm getting negative 10. When I combine them, I'm getting negative 3. Okay, so to get values for x, I just have to do a simple change over here. That is, I have to change the signs of these two factors to get the values of x. So then the first value of x is going to be, so positive 5, because here we have negative 5. If I change the sign, I'll be getting positive 5 as one of the values of x. Here the second factor is positive 2. So from this factor, the second value of x is negative 2. Okay, I got two values for x, 5 and negative 2. So always it is advisable to check the values what we got for x with the equation. So usually we have to do it whenever we solve a logarithmic equation, because even though we get two solutions for x over here, sometimes one of the two solutions may not satisfy the given logarithmic equation, so we have to exclude that one. So always if you solve a logarithmic equation, it is advisable to verify the solutions what we get. Okay, now let me verify the first solution. That is x is equal to 5 over here. So I'm going to plug in x is equal to 5 into the given logarithmic equation. So I'll be getting log 5 to the base 3 positive log 5 negative 2 to the base 3 equals to log 5 positive 10 to the base 3. So log 5 to the base 3 positive log 5 negative 2 is just 3 to the base 3 equals to log 5 positive 10 is 15 to the base 3. And here two logarithms are in addition with the same base. So we can take logarithm once with the base 3 and we have to multiply the arguments according to the product rule of logarithm. So here 5 times is 15, log 15 to the base 3 equals to log 15 to the base 3. So the stuff on the left side, the stuff on the right side are equal. So the given logarithmic equation is satisfied by x equals to 5. So x equals to 5 is an accepted solution. Okay, now we have to verify the second solution, negative 2. To verify the second solution, I'm just going to plug in the same thing as I've done for 5. So I have to plug in x is equal to negative 2 into the given logarithmic expression. So let me do it. So log of negative 2 to the base 3. Okay, I'm not going to continue further because even for the first logarithm, the argument is negative. So for any logarithm, the argument can never be a negative value. Always the argument has to be greater than 0. Even argument cannot be 0. So for example, if I consider log x to the base 3, so the argument over here has to be greater than 0. It can't even be 0. So or negative. So here even for the when I plug in negative 2 for x, even for the first logarithm, the argument becomes negative. So negative 2 will not satisfy the given logarithmic equation. So it is not acceptable solution. So there is only one solution for the given logarithmic equation, that is x is equal to 5.